Welcome back to Wildcat Academy. Today we'll be multiplying and dividing rational expressions. So in examples 1 and 2, we'll be asked to multiply the two rational expressions and then state any restrictions on the variable. In example 1, we have monomials in the numerator and denominator of both fractions or both quotients. And so we will just simply cancel those from left to right. We can cancel the numerator of one side and the denominator of the other. Similar to the way we would cancel, let's say, 2/5 times 15 over 6. We would divide the 2 and the 6 and get 1/3, and we will cancel the 15 and the 5 and get 5 over 1. And then our resulting answer will be 5/3. So returning back to example 1, we can look at the 4 and the 12, and we can divide those and realize that they have a common, they can both be divided by 4. So divide the numerator here by 4 and get 1, divide 12 by 4 and we will get a 3. We cannot do anything with the 8 and the 5, nor the 8 and the 3, so our constants are now been simplified. We can look at the variables, and we can divide the y's. They will simplify to 1. And then we can divide x squared and x to the 4th. And they will cancel, leaving an x squared in the denominator. And then you just write down what you have left. So all the 1's times 8 is 8. And then 5 times 3 is 15. X squared. A little tricky there to keep track of everything as it simplifies and cancels out just one step at a time. You can even do that in 2 steps. You can cancel in 2 steps if you like. You can multiply them together and then simplify if you like to do that, as long as they're monomials. I think that works out really well. In example 2, we have some linear binomials. So we're looking for greatest common factors of each binomial, and we will factor those out. Remember that we're going to completely factor each numerator and denominator and rewrite those, and then we will cancel or simplify from there. So 2x and 12 are both divisible by 2, so we'll divide the 2 out, put it outside the parenthesis, and rewrite the binomial inside as x plus 6. Always check. You can redistribute that. 2x times x, or 2 times x is 2x, 2 times 6 is 12. And we'll do something very similar with that denominator. We'll divide the 3 out. And then we will divide the 2 out of this numerator, 2x minus 6. And we will divide the 4 out of the second denominator. And from there, we will just cancel our common terms. We'll cancel out the x plus 6, the x minus 3. 2 times 2 is 4. Both of those will cancel with this 4, and we're left with the 3 in the denominator. Looks like this simplifies down to 1/3. Now, something we forgot to do on example 1 and we have yet to do on example 2 is list our excluded values or our restrictions on the variable. So we can see that we cannot plug in 0 for x. X cannot be 0. And we also had a second variable, y. Y cannot be 0 as well. So those are our restrictions. Anything that would cause division by 0 will be a restriction on the expression. And in example 2, we'll go back to our completely factored form. We will look at our what would cause division by 0 in both the left-hand side and the right-hand side quotient. And looks like x cannot be 3 and x cannot be -6, because 3 minus 3 is 0 and -6 plus 6 is also 0. In example 3, we have a little more complicated numerator and denominator, but our process is still exactly the same. We're going to completely factor the numerator, x squared minus 9, that's the difference of 2 squares. And there should be some links up in the upper right hand corner throughout the video that will take you to factoring videos. There will also be links in the description of the video if you need a reminder or refresher on how to factor. And then we will factor this trinomial into x minus 3 and x minus 3, because negative 3 times negative 3 is positive 9. They add to be negative 6. We can do that as long as the leading coefficient is 1. Very simple check there. And then same thing in the numerator here, x plus 2 and x plus 3. And then the difference of two squares, we'll take the square root of both, and they will become conjugates. One will be positive, one will be negative. And then we will cancel in a one-to-one fashion common factors from the numerator and denominator. So x minus 3's, there is an x plus 2 though. And that looks like, be careful that you pay attention to the signs. It'd be tempting to cancel the x minus 3 and the x plus 3 here, but we cannot do that. They are different signs. Remember, you can never cancel an x out of the parenthesis. You can't just cancel the x's and get, or the 3 over negative 3 and get 1 over negative 1. That doesn't work. These are connected together. You cannot separate those canceling. They're connected by addition and subtraction, so that does not work. So we will just rewrite our rational expression, the factors that are left. We'll get with x plus 3 times x plus 3, which is x plus 3 squared, over x minus 3 and x minus 2. And then we need to list our excluded values. Our excluded values are going to be positive 3, negative 2, and positive 2. Those are the values that x cannot take. In example 4, we have two rational expressions. And we're going to be dividing those. And just a quick reminder that if we're dividing two fractions, something like 2/3 divided by 6/7, then we don't actually divide the two fractions. What we actually do is we change the operation from division to multiplication, and we flip the second fraction. So we keep the first fraction, we change the operation, and we flip the second fraction, or we multiply by the reciprocal. And then we will simplify if possible. And you see we can simplify the 2 and the 6 by dividing both of them by 2. We end up with the answer, and then we multiply across, we get 7 over 9. So again, remember that in order to divide two fractions, you keep the first fraction, change the operation, and flip the second fraction. This is commonly referred to as keep, change, flip. So returning to example 4, we will factor the numerators and denominators completely. So that'll be our first step. So we will change that to x squared. We will factor x squared minus 10x plus 21 into two binomials. And we'll choose factors of 21 that also add to be negative 10, be x minus 7 and x minus 3. We will change, we will wait one step to change the operation. You can do it in the one step, but I want to factor in the first step, and then I will flip the fraction in the second step. So go ahead and completely factor, and then we will keep the first fraction. We will change the operation, and then we will flip the second fraction. We get x plus 3 times x minus 3 all over 3x, and then we will cancel common terms or divide them. We'll divide x minus 3 by x minus 3. We'll divide x squared by x, and then we will rewrite all the terms that we have left. We'll have x times x plus 3 all over 3 times x minus 7. And in order to find the excluded values on a division problem, we have to check the denominators of both the flip step and the multiplication step. And the reason that is because in the factoring step, we will check each individual quotient to see if what will cause it to be 0, the denominator to be 0, I should say. And so that we'll check here right here. We'll set x minus 7 equal to 0, we'll get 7. X minus 3 equal to 0, and we'll get positive 3. And we have negative 3, and then positive 3 we've already listed. So those are 3 excluded values. But then we have a larger division problem, So anything that will make this second fraction 0, which then refers to the numerator. So anything that will make the numerator 0 of the second fraction will cause the entire division problem to be undefined. So then you can see that happen right here in the flip step. So we have to go back to the flip step and check our second fraction to see what will cause division by 0, and there's a 0 there. So we have 4 excluded values. A little tricky, but as long as I think you're careful and pay attention to detail here, I think you'll be fine. Just check, both of the original 2 fractions for division by 0, and then check. Then you have to find the zeros of the numerator of the second fraction, because when we flip it, it becomes the denominator. Or you can think about it being the larger fraction up here, what will cause division by 0. Alright, so that winds up example 4. Let's look at example 5. So we're going to go ahead and factor the numerator, 3x minus 12. That has a GCF of 3. We end up with x minus 4 in parentheses. Then we'll factor x squared minus 9x plus 20 into x minus 4 and x minus 5. We will continue with division, but we'll just factor x squared plus 7x into x plus 2 and x plus 5, because 2 times 5 is 10, and then 2 plus 5 is 7. This binomial, we're going to factor out a GCF. It's going to be 2 steps. I'm going to go ahead and do 1 step right here underneath just to save some room for calculation. And then we will have a difference of squares, x squared minus 25, so it ends up factoring to x minus 5 and x plus 5. And then we will do our flip step. 3 times x minus 4. Rewrite the first fraction, x minus 4 and x minus 5. Change from division to multiplication. And then we will flip the second fraction, 3 times x minus 5 and x plus 5. And then we will end up with x plus 2 and x plus 5 in the denominator. We cancel our common factors that are present in one-to-one fashion in the numerator and denominator, because we're dividing those to be 1, remember. We have x minus 5 divides out, x plus 5 will divide, and we end up with 3 times 3, which is 9 over x plus 2. Our excluded values, we have to go to both steps. We'll end up with positive 4. X minus 4 gives positive 4. And we'll get 5 and negative 5. And then on our flip step, we have one more value here that we haven't listed, which will be negative 2. We end up with 4 excluded values that we cannot plug back into our expression. Our expression will be undefined for. So the answer to example 5 is 9 over x plus 2, with excluded values x not equal to 4, 5, negative 5, or negative 2. If you found this video helpful, be sure to hit the like button below, subscribe to the channel so you can be notified when we release our next video, and leave a comment down below if you have any questions over multiplying and dividing rational expressions.